Welcome to lecture number 3 for chapter number 3, Systems Administration Part 2. You can find the content of this chapter in the textbook on pages 51 through 81. So standard agenda, I'll be reviewing what we talked about in the last lecture and last chapter. I'll summarize what the chapter and lecture objectives are for this chapter. I'll get into the lecture and I'll hit the review questions that are going to help you out in terms of the assignment and also with your quiz. So last lecture and chapter, what we talked about was systems administration. We talked about exactly what systems administrators do in terms of installing, configuring, access management, access control, configuration, that type of thing of systems within an organization. And it's important to information security because they are often the first line of defense that are required within an organization for cybersecurity, and they are often the only line of defense that are available. Some of the key technologies that they use is virtualization that allows them to manage large amounts of machines very effectively. You can install many different virtual machines on a single machine, that type of thing. And they also use Linux as one of their popular mechanisms to administer machines across the network. It's very popular because there's different types of flavors, highly customizable, open source, that type of thing. What we're going to be talking about today, it's going to be a slightly different type of lecture today. I'm going to be doing a little bit of hands-on stuff so that you can see exactly how to execute some of these systems administration tasks. So last lecture we talked about operating systems briefly, about how systems administrators are required to use different types of operating systems across their organization, install and configure different types of software, and that type of thing. We'll identify what are the components of a modern operating system, what exactly is there. Then we'll summarize how to exactly use Linux to do some systems administration tasks. So we'll talk about how to use the command line interface, how to execute basic operations, manage file permissions, user accounts, manage software packages, and that type of thing. So let's just go ahead and do a quick recap real quick. First, systems administration is a set of functions that provides support services, ensures reliable operations, promotes efficient use of the system, and ensures that prescribed service qualities are met. And systems administration functions include installation, configuration, and maintenance of network equipment and computer systems. And these network equipment could be switches, routers, and so on, and computer systems could be databases, email servers, ERP systems, and so on. And the relationship to the CIA triad is that they're often the first line of defense for all three dimensions of the CIA triad. So for example, confidentiality, ensuring that unauthorized people cannot read or copy transcripts. Integrity, making sure that the quality of the data information is maintained, and availability, making sure that the database server that students need when they are trying to access the database for their assignment is available to them at 11:50 p.m. right before the due date at 11:59 p.m. on a Friday night. Some of the common systems administration tasks include installation, configuration, access control, user management, monitoring, and updating. And all of these are typically done within the context of an operating system. And remember that there's different types of operating systems that may be available within a network, within an enterprise network, such as Windows 7, Windows 10, different types of Mac OS, Linux, and so on. And with the events of 2012, specifically with the number of mobile devices exceeding the number of desktop devices, mobile devices are also very important to know about as well in terms of the operating systems that are available, and these breakdowns may vary based off of industry. Also recall that Linux is popular for systems administrators because it's open source, it's easy access to the command line, it's oftentimes free, it's very lightweight, and so on. And there's many types of Linux distributions that are just for cybersecurity applications, such as Kali Linux, ISI Linux, which I co-developed, Tails, Unix, and so on. So let's get into specifically the lecture today. So we know more about systems administration, the different types of tasks that they do, and so on. And they're really managing different types of operating systems across their entire network. So an operating system, we have all used it. It's a software that manages the computer hardware and provides common services to user applications. The value of it is that application developers can ignore the details of the underlying hardware when developing applications. We don't necessarily need to know about the CPU cycles, we don't need to know about the power supply, we don't need to know about the memory and how they all interact with each other and so on. And it greatly simplifies application development, not just application development, but application usage. I can use Mozilla Firefox, I can use Google Chrome without worrying about the underlying hardware of my system. Now, if it starts getting maxed out, then I absolutely have to worry about it, but I can get by without not having to know very much about the hardware of my system, and most consumers, I'll argue, actually don't know very much about the hardware on their systems. They get to just use the operating system, and it's very, very effective for them. Let's go ahead and actually break it down and make it a little bit more technical. There, you can see up top that there's a user applications. This is often what we interact with, is the user applications. There's the shell, which I'll get into in a second. There's a kernel, device drivers, and the hardware. So the hardware are things like your computer keyboard, that would actually be a peripheral, but then there is your memory sticks, the hard drive, the power supply, the CPU, and so on. That's the actual hardware. The device driver sits in between the hardware and the kernel. So if you can remember pre-Windows 8 days, before the drivers were installed automatically, the drivers you often had to install. So for example, a printer driver, and the driver allows you to go ahead and have that piece of hardware communicate with software. The kernel controls all the hardware devices. It manages the memory, and executes the code on the computer CPU, and it hides the underlying physical hardware from the applications. So it's really the layer in between the user applications and the driver/hardware. Now the user applications we're very familiar with. That's just a double click on Google Chrome and we're able to access an application that will allow us to execute a particular task. But the shell is a text-based program that allows the user to interact directly with the kernel. So instead of using a GUI, a graphical user interface like what we're all used to, command line is a text-based interface that allows us to go ahead and start to run commands to start to get more finer grained control over the kernel such that we can get finer grained control over the hardware. Now you may ask, why would anybody ever want to deviate from the GUI? It's significantly faster. You can script, you can automate a lot of work. It's low network bandwidth needs. It's the primary interface for many systems administrators. More importantly, however, is that the GUI actually, it has its own security risks associated with it. Remember, every time you add on a new layer of technology, that technology is going to have some form of a security risk associated with it, whether it be a patch or an outdated piece of software or that type of thing. Now, what's most important is that the command line interface allows you to access that kernel with a higher level of security, and you're able to do it a lot more effectively as well. So in Windows, you have the command line, but then you also have things like PowerShell, which allows you to get more access into the system and so on. The shell is in a Unix and Linux system is ready on OS startup, and it's easily accessible from Windows. So the shell is something that is a very powerful tool, and when you're interacting with a lot of Linux-based cloud computing systems, all you're going to have access to is the shell. Some of these operating systems, you're only going to have access to the shell. Now, when you're a hacker, you're often trying to get access into another machine. But when you get access to that machine, you may not actually get access into the GUI aspect of it, but you may get access only into the shell. So you need to know how to navigate through that. So the shell history, I'll show you what it looks like within Linux in a little bit. You can see a little bit of shell history right here. It was originally developed by Stephen Bourne in 1979. It was a de facto standard in Unix. And then it just evolved from there. So what I'm going to do now is it's going to be a little bit different than other lectures. I'm actually going to go ahead and get into the VM that we have for the class. So I've already downloaded it and I've installed it into Oracle VirtualBox. And I've got the username and password from the textbook. So let me log in. So once I've logged in, I can see my desktop right here. Now, what you can see here is this is a GUI-based interface. So I can go ahead and double click, and then I can go ahead and access the desktop. I can see all the files in there. I can go into work, pictures, you know, that type of thing. Exactly how you're used to seeing it. And I can navigate back and forth, that type of thing. Now, this is all fine and dandy, but the shell is actually very, very powerful. Let's go ahead and go into the shell. So to get to the shell, you go to Applications, System Tools, and then Terminal. And mind you, this is the way that it's going to look like. And the shell, the terminal, the command line, they're all kind of synonymous with each other. They all bring it to this type of thing, where it's a text-based interface that allows you to interact with the operating system, with the kernel specifically. So if we break down what this is, each aspect of it, you can see that on this part right here, Alice is actually the username that we're at. This is the computer that we're connected to. The computer's name is Sunshine. This is the current folder that we're at right now. And then this is the privileges that we have. And the privileges are ordinary and root. Ordinary means you're just a standard user on a computer, and you may not be able to access everything on that computer. Whereas the root means that you have access to everything on that machine. You can install whatever you want, you can access whatever you want, that type of thing. But a standard user, you may not have that ability. So remember that with the systems administrator, we can perform, they perform many different tasks such as installation, configuration, access control, user management, monitoring, and updating. But you need to first understand how to navigate through Linux, through the shell, not through the GUI. So I don't want you to really learn how to go through the GUI right here. Everyone can go through the GUI. It's very, very simple to go through the GUI. You just double click around and you find where you're at and so on. But I really want to get you used to the shell aspect of it. And why? That's the key reason. Why do we want to do that? Number one is that not all Linux distributions have a GUI. A lot of them are only command line interface. And those ones are often very popular for managing complex information systems within a network. Number two is that the shell gives you significantly more control over the machine to execute systems administration tasks. Once you get used to it, you can actually do a lot more things from the shell a lot faster than what you could do in a GUI. And in fact, there are many tasks that I personally use in my own research that is much faster to do in a shell, in a command line, rather than doing it in a GUI. And finally, like I mentioned before, when hackers hack systems, they typically have access over the shell. The familiarity of the shell will help you take the perspective of black hat, which is a key skill that our employers want. What will a black hat hacker actually see if they were to actually break into your system and get to the shell? So what we're going to be covering for the remainder of the slides is we're going to be covering a few key aspects. First, we're going to do basic Linux navigation. I know that many of you don't have Linux experience, or you may have only GUI-based experience within Mac and that type of thing. But this will help you get confidence in terms of how you can navigate through Linux. So you'll actually see it's not that difficult to do. So we'll talk about how to navigate through Linux. So navigation through the GUI is very simple. You can just double click around. You can find where you're at. I can go to the work folder. I can see the files in there and so on. I really want to see you get comfortable navigating through a shell. Two, I'm going to ask you to get comfortable with file management. So moving, copying, removing files and folders, all those types of things. Third is viewing files and contents. And then fourth is searching. All the different types of things you can do through a GUI, we're going to show you how to do that through a command line. Then what we're going to cover is software installation and updating. Remember that one of the key aspects of systems administration is installing and updating software. And also managing users, so adding and managing user/groups. Configuration and monitoring we won't be covering in this particular lecture. We'll be talking about that later on in the course. So let's jump right into it. Linux navigation. Linux navigation is just like Windows or a Mac. Each folder or directory has other folders or files in there. So let's go to my personal directory right here. This is my directory for assistant professor content because I'm an assistant professor. Within this directory, I got additional directories, and this is like grants and awards, right? So then there's subdirectories in there. And then within there are different files that I can start to look at. So that's the exact same way that you'll find it within a Linux system. So if we go to the GUI real quick here, we can see that there's the work directory. Within the work directory, there's different files that are available in there. So we can continue to break it down, and you can see that these are the paths that you can take. So this path right here, in order to access this file, you go to Home, which is right here. You go to Bob, then Sample, then file2.txt. That's the path that you take to get to that particular file. So that's the basic intuition. Now, one of the key things that you need to know is that the difference between an absolute and a relative path. An absolute path is exactly where that file or folder is. So if we go back here, the absolute path is /home/bob/sample/file2.txt. That is the absolute path. If you were to try and find that on an operating system, the operating system would be able to find that particular path. A relative path is the location of a file or a folder in relation to the current directory. So let's say that we're actually in the sample directory right here. What's going to happen is that file2.txt is the relative path. It's file2.txt in this particular location. There could be a file2.txt in the Bob directory right here. So simply saying file2.txt when you're at the root directory right here is not going to give you the path to actually getting to file2.txt. So the relative path is only within a directory that you're currently in, whereas the absolute path is exactly where that file is. The other thing too is that Unix file systems are case sensitive. So /usr, that particular directory, is not the same as /USR or all capital USR or US and then capital R and so on. Those all have very specific meanings. Let's talk about how we can actually navigate through. So if there's a few key commands that we need to know of. Number one is pwd. Say that you're in a directory, but you don't exactly know which directory you're in. pwd, if you type that in, it tells you exactly which directory you're in. So you're in the /home/Alice directory. Changing directories, let's go ahead and list out what are all of the directories that are available to us. So if we press ls, which is list, we can see that these are all of the directories that are available to us. So if you take a look at the GUI, if you were to go to Alice and then you were to list them all out, list out all the directories, you can see that these are all of the directories right here, and that's all reflected right here in the command line. So in the command line, we can see the exact same thing in the GUI, without all of the pretty pictures and such. Now let's say that we wanted to navigate into a particular directory. Say that we wanted to navigate into the work directory. Typically in a GUI, we would just double click and we'd be able to navigate into the work directory. However, within the command line, what we're going to do is we're going to press CD. C stands for change, D stands for directory, so it's CD, and then we're going to specify the directory that we want to go into. So let's go ahead and type in work. So now, if we list out all the files again, we can see that the work directory, we access the work directory, hello.txt, hello-world.txt right here. And we can see those exact same things in the command line right here. Now remember, everything is case sensitive. So if we wanted to go back one directory, the command would be cd ... space ... and that would bring us back to the previous directory. So now we can see everything that's there. If we wanted to go into the work directory and we accidentally do what a lot of security professionals call fat finger, and we accidentally capitalize one of the letters, no directory called work with a capital W is going to be available to us. So we're going to do cd work. Then we can list out all the files in there, and we can see that what's in there. So let's go ahead and clear out the terminal. Get a little bit cleaner view for us. So cd is the command. So if we wanted to do this, let's go back one, clear, ls, so we can see, cd, ls. So now we're back to the root directory. Clear, okay, ls, So now we're back to the root. So say that we wanted to CD, right? So CD is a command. We're telling exactly what we want the computer to do. That is a command. We're telling the computer that we want to do this particular thing. CD and then space, and we could type in work. Work would actually be what's called an argument. And that's an option. That's basically something that is a relevant piece of information that will help the computer execute the command. So what we want the computer to execute is we want it to change directories, but we need to tell it exactly where we want it to change directories. So most of the commands have meaningful details. So CD without arguments will just take you back to the home directory. So let's go ahead and do CD work. So CD is the command, work is the arguments. That's where we're going. And mind you, this type of terminology is something that will help you out if you decide to go down programming and so on. So now CD without any arguments will actually take us back to the home directory. So now we're back in the home directory. Okay, let's clear that out. ls, we talked about that before. ls, it lists out everything. Now that's a command. There's also things that are called options. We can have options that are listed out, or also known, sometimes referred to as arguments. But the options here is that it'll give us the ability to actually do certain things that are more beneficial for us. So right here, what you can see is that all of these are listed out right here. But say that we wanted to distinguish between what is a file and what is an actual directory. So what we would do is ls hyphen capital F. What happens is that all of the folders or all of the directories has a backslash behind it, whereas a file is just txt. And that's just one example of an option that you can have. Many, 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 many other options are also there. They're also called flags or switches. And these types of flags and switches allow you to do many different things. So you can combine different options together. And many commands have many, many, many options. I strongly suggest that you go ahead and Google what those options do. And a lot of those options really just make life a lot easier. So let's go ahead and just let's do some of the things that we can do with options. So ls and then AL. So A, show hidden files, and then L, show the details of those files. So you can see all the hidden files that are available, what are the details, who can read, write, who has access to it, what's the name, when it was last modified, and that type of thing. And these types of things help you get a lot of information out of your system very quickly. Whereas in a GUI, you'd have to right click and go to properties, and you may not know exactly where to go, and that type of thing. Right? So what you can do in a command line is get that information very quickly for a large amount of files and directories very effectively as well. So you can start to see why it's actually much easier to navigate through much more quickly through the command line rather than through the GUI. Again, some more examples right here. Now, say sometimes you may be a little bit lazy, you don't want to type anything out. Let's go ahead and ls, see where we're at. Let's clear this out. ls, and then we want to go into the work directory. Sometimes we don't want to type out work, so we can type out W and then press tab and it'll fill it out for us. We can go in. Now let's do an interesting example. So right here what we can see is hello.txt and hello world.txt. So say that we wanted to only get access to hello or hello world.txt, we have to actually type out hello. If you type out hell and then tab, it's not going to actually know what to do. But if you type in hello underscore tab, oh, that actually didn't work. We'll get to that in a second actually. You can also do things like shell expansions. You can start to do wildcards, so it can match out any sort of file. So if we do ls and then star, so match anything 0 or more characters .txt, it'll list out all of the txt files. And you can start to really navigate through your file system a lot more effectively. So let's see if we can actually create a document, empty file. Let's do test .sh. So that's an sh file. So ls, we can see that is test.sh. So if we were to do ls and then star.txt, it'll only list out the txt file. So if you wanted to sift through your directories very effectively, very quickly, you can start to use these wildcards to go ahead and do those things. And those actually are a form of regular expressions, which we won't get into here, but that's essentially a very easy way to do string matching and that type of thing. File management. So one of the things that you often have to do as a systems administrator is that you have to make files, you have to make directories, you have to remove directories and so on, especially when it comes to user management. So making directories is actually quite easy. So if you go back to the GUI, right click, and then create folder, and then you have to name it and that type of thing. But let's go ahead and actually, let's just delete this right here. Let's do something that's a little bit more quick. So ls, we can see that these are the files that are available to us. So if I wanted to make a directory, let's say mkdir, so that's make directory, and then new directory. And that new directory, this one right here, is actually the name of the directory that we want to make. So let's go ahead and make that. So now we can see that a new directory popped up. So if we press ls, we can see the new directory that came up. So if we want to do ls and then -f, we can see that that's the directory that came up. Now say that we accidentally made a directory. Let's go ahead and actually remove that directory. So rm, remove directory, and then new tab to autocomplete, and remove the directory. And you can see that the directory removed right here. Say that we wanted to go ahead and copy and move files, right? Same sort of concept. So the concept is, here's the command, the source, which is the actual name of the file that we want to copy, and then the target where we want to copy it to. So let's say that we wanted to copy it, CP, we want to copy the hello.txt file, so that's the source, hello.txt, that's the source, that's the file that we want to copy, and then the target is we want to copy it to hello world.txt. Now if we were to do ls-af, remember those are different options for us. That'll tell us what is available for us in that directory. We want to move a file. Let's say that we want to move it and we want to change it from hello world.txt to hello world.txt with all capitals. So we could do mv, which is move, hello world.txt, which is the source. That's what we want as the source. That's what we wanted to begin with, right? And then hello world.txt. That's where what we want it to be. So then it's moved. So if we do ls-af, we can see now it's hello world.txt that came up. Okay. Recursion is if a folder contains folders and files within those folders, and then so basically a bunch of different folders within folders, and then files within those folders and that type of thing. Copy will only operate at the top level files, so it'll only copy what's at the top level. It's not going to go iteratively through all of those folders and so on. But recursion causes copies to be made within folders, so sometimes it's useful to copy entire directories. You can copy those entire directories very effectively through the command line as well. And you can see some of the commands right here. Removing and deleting folders and files. I'm not going to go into how to actually do this, but the remove command RM is extremely powerful. You can start to remove a lot of different files, a lot of different folders very effectively. CP, copy, MV, move, and RM are all invasive commands. That means that there's no recovery that's possible. The -I option adds interactivity. So warnings appear if the operations will delete existing files. So it'll ask you, are you sure you want to do these things? It'll be N or Y and that type of thing. And the N stands for no, Y stands for yes. And it's just double checking to make sure that you actually want to do that particular invasive command. Removing folders, RMDIR works with empty folders. RM space hyphen target deletes the folders with the content. And that's very, very dangerous. Now, RM-R/ will recursively remove all of your folders. So if you want to be really mean towards someone, you can go to their root directory where everything is stored. You can get access to all of the different directories right here. You open up the terminal and then just run this command. It'll delete everything off their machine. You don't want to do that. Sometimes you want to go ahead and view text files. So we saw that there's text files in there, right? So let's say that we wanted to go into those text files, so ls, and then we want to do something like just view the name of the what's inside of the text file without actually opening up. So here we would actually have to open it up, right? So we'd say hello world there. Let's go back here. So ls, we see hello.txt is available to us, but we don't want to open up the file per se. We can go ahead and we just see the first few lines of what's in there. So we can say less hello.txt, and we can see what's in that file. Okay, we're going to close the terminal, open up a new one, and so on. So the keyboard shortcuts, many of these keyboard shortcuts have actually carried over to modern software. Many of those you're actually using and you don't even know about it, and they are driven from a Unix system. You can view portions of files, which is exactly what we did. Sometimes it's very helpful to do that just to see what are the files that you're working with. So you can actually do combinations, so you can start to do some searches like, just identify what are the files that are TXT files, and open up those files and look at the top and that type of thing. So you can get very creative and go through very quickly a lot of different files on your system. And these are just examples of that. You can also search for files. So if you wanted to go ahead and search for files, you can do that. So the way you can search for files is find space / and then the name right here, and then the file that you want to search for, http.d.conf. And what actually comes up is that you start searching for files and it says permission denied, and that actually brings us to another lesson. We're the standard user Alice right now, but if we wanted to, we could get what's called root privileges by doing su or sudo super user and then running the same command, and that'll actually give us the ability to search through all the files without a problem. That'll give us root ability. Editing files, there's something called VI and Vim. I'm not going to go ahead and go into that. That's a big rabbit hole right there. But VI and Vim are the standard text editors that are available on Unix systems. They're very popular, very, very powerful. There's a command mode and the input mode. You're allowed to start to develop your own text files very, very quickly and very effectively as well. So we could open these up with Vim if we wanted to. We could open it up with Gedit also. I prefer Gedit because it's a little bit more friendly, but VI and Vim is very useful for you to have, especially for Linux systems that are not GUI based. So you don't have access to a GUI, but you can actually, you only have access to the command line. So VI and Vim will actually give you the ability to edit those text files and start to put in new content in those text files very effectively. And so there's different ways that you can do that. I'm not going to go into this. It's not as important for you to know this particular concept, but it's still good for you to know that it is one of the baseline text editors within a Linux or Unix system. Find command, we talked about that. So that's basic navigation. The last set of slides is really about the basic navigation, that how do you go through a Linux operating system, how do you navigate through that, and so on. Now we also talked about that systems administrators often have to do software searches, installations, and updates. Within a Linux or a Unix software, it's called a package. It refers to all the files of the application that are bundled together as one file. It's comparable to the ISO files that are used within a Windows software. So software is managed by applications called package managers. And the way you use package managers is you type in apt in a Debian-based system, RPM in a Red Hat system, PKG, util in Solaris, and so on. Within the flavor of Linux that we're using called CentOS, we're actually going to be using a command called yum. And that stands for Yellow Dog Updater Modified. And as we had mentioned before, Linux is an open source software. So we can actually go into the underlying code of that particular piece of software. Additionally, what open source software allows us to do is it allows us to get access to open source packages. And there's entire repositories that people have put together out there that provide many, many, many free packages that are available. So for example, there is a package for LibreOffice, which is a form of Microsoft Office designed specifically for Linux. So we have those repositories that are available to us. So let's actually go ahead and start to mess around with that and start installing some software. So if we do yum list, what comes up is that it comes up with a list of all of the software that's available to us, basically. So we can start to search for software as well. So if we do yum search, we're interested in finding games, for example. We can see all the games that are available to us. Then we can do something like yum install GNOME games. Now it tells us that we actually have to be root in order to perform this command. So if I were to do super user, and then we have to type in what the username or the pseudo password is for the root password. It actually tells us that Alice is not allowed to execute this particular command. So say that we had that ability, then that would actually give us the ability to install packages and so on. Yum update allows us to update all of the software on the system. I'm not going to go ahead and do that. And it trusts that the developers have done a good job. Now, there's a trust factor that's there, right? And that's a security issue in and of itself, is how do you actually make sure that the updates are legit, that the updates don't have any sort of issue associated with them and so on. Now also remember that with the systems administrator job, they are also required to make sure that the software that's being installed is legit and that it's being managed accordingly. Remember that a consumer often wants to install everything when they're in doubt, but a systems administrator has to make sure that they install only the necessary components such that they can update what's needed accordingly. So that's from a software update and installation point of view. From an access control and access control list, remember that sometimes we want to add users and also edit their permissions, what they're able to get access to, and so on. So files need protection, so that helps out with confidentiality and safety, and the end user should be able to delete the server, should not be able to delete a server configuration by accident or something like that. And there's two mechanisms that are available to us that will help out with ensuring the confidentiality, integrity, and availability of particular files and folders on a system. File permissions. So this is very traditional. You have access to this, I have access to this for this reason. An access control list. So it's fine-grained, it's relatively new, and it's limited tool support right now. So who gets access to what? So you can actually see what the file permissions are for each file. Remember that we had that command before that allows us to actually see what are the different file commands that are available to us. So let's see if we can actually find that. Focus this on. Whoop. I think I've lost it here, but you can actually see what the permissions are. So you can see all of the permissions that are available for each file, who can access it, who can modify it, who can do all those things. So you can see each of the columns that are here, they link up with a particular aspect, and you can see how that breaks down right here. So the file name, the directory name, and so on is all broken down within that particular file dimension. So the first column is the file directory permission. So for example, this right here. Second one is the number of file system hard links, the file directory user ownership, the directory group ownership, and so on. So you can see who has access to what and at what level as well. So you can see that the first column, ls to al, outputs 10 characters, e.g. this right here. And it's actually two sets of information. The first character is the file type. And second, the remaining 9 characters is the file permission. So the file type, the D, represents a directory, whereas a hyphen would represent a regular file. Then you can see all the permissions associated with it as well. And the permissions are 9 characters, 3 sets of 3 characters each. So RWX is owner, R through X is group, and R dash dash is world. So the file owner is the first 3 characters. Who specifically owns the file? Second 3 characters is the file owner group. What is the group of people? And the last 3 characters is everyone else. R indicates that it's a read. It only has read permission. W indicates that you can read and edit the file using a text editor. And X indicates a permission to execute the file. So you can actually perform a command on that file. So for example, RWXR hyphen XR hyphen hyphen, owner can read, write, and execute the file, RWX. Group can read and execute the file, but not edit, so RX right there. So read and execute, but they can't edit the file. So it's R and X. And then everyone else can read the file. So the first 3 characters, remember, refer to the owner. What can the owner do with that particular file? RX is what can a group do that particular file. Say there's the department head of a department, they can own the file, right? They're the owner of the file. They can read, write, and execute it. Whereas a group may be the entire department, so that they can only read and execute. And then the entire world, which may be the entire college, can only read the file. Executing permission for a user is specified by the 3rd character. So X indicates the execute permission is available, and dash hyphens indicates that the user / group cannot execute the file. And other values are also possible for this position. Octal notation, many administrators prefer to use shorthand to represent file permissions. It's supported by most commands. And permissions can be interpreted as a 3-bit number. Read permission is 4, write permission is 2, execute permission is 1. So that you can just go ahead and associate the R with the 4, W with the 2, and X with the 1. And the permissions also add up. So 5 is equal to 4 plus 1, read and execute permission. 6 would be 4 plus 2, and then 3 would be 2 plus 1, and so on. Then that would be equivalent to W and X. So 755, the first number right here is referring to the owner, second number is to the group, and third one is to the world. The 7 refers to read, write, and execute. It's 4 plus 2 plus 1. Whereas group is 4 plus 1, that gives us 5. And then also world is 4 plus 1. So it's they can read and execute, but they cannot write. And then 644 would be the owner can read and write. Then the group and the world can only read. And it's 664, 660, 777, all similar things. So 777 is that everyone can do everything to the file. You may not want to do that. Now, here's the key thing, is that you're defining these roles and these permissions, but that's very much defined not off of what you desire, but off of the business needs. What are the key business needs that an organization has? Who can get access to what and when? Those are all critical questions. That's more from a business point of view rather than an actual technical point of view. What if you want to change permissions? So for example, A group does not have a permission to write to an engineering directory. Say that we want group members to write permissions on the directory. chmod can update the permissions on files and folders. And this generally requires super user or sudo or root privileges. And the owner can also change the permissions if they have the ability to do it. So su confers super user privileges, su and then hyphen, enter the root password, and then you see that this hash right here actually is a change in the prompt. That means that you have super user privileges, whereas before we had the $sign. So once you're at the hash prompt, be very careful, because now you have access to everything on the system, and you can make some really, really big damages inadvertently too. There's been times I've crashed my entire Linux machine or done something on it that I just can't access any of my files anymore. And I felt very, very sorry and very bad about that later on. So before chmod, you can start to you can see what it looks like. And then after chmod, now you can see that this particular group right here has access. They can write to this particular file as well. You can also start to do access control lists, a fine-grained application of permissions, so you can start to do that for specific types of files and so on. File ownership, you can change who owns the file, so chown, C-H-O-W-N, change ownership, and then C-H-G-R-P, change the group. So you can see that you can change the group, you can change the owner for Dave to something else, and you can change the group of who owns the file to the sales group. And in terms of adding user account management, you can do system, administration, users and groups, and then you can start to add users from there and entire groups from there as well. You can manage groups in terms of what you want to do with them as well. I'll put them IDs on them and that type of thing. And once you put IDs on them, then you can start to specify how you want to manage the groups, what you want to give permissions to, what are the different types of ownerships that you want to have on it, whether you want them to write, you want them to read, and so on and so forth. So at that point, the world is really your oyster, and you can do a lot of this very, very quickly if you are a system administrator through Linux as opposed to, say, something else on a Windows machine or a Mac OS X. So let's go back up high level. What exactly did we cover? We covered Linux, how to navigate through Linux, what are the basic types of commands, moving, copying, removing files and folders, viewing files and folders, searching through them, looking at options, doing different types of commands, and so on. We talked about software installation, so we talked about yum, the updating, the access control, the user management, and think about how each of these relates to the CIA triad. With confidentiality, you want to make sure that people who aren't supposed to be seeing the files aren't seeing the files. And now we have an idea on how to actually execute that, how to actually implement that. We can start to change the permissions. We can use the octal notation and so on. And the configuration monitoring we'll be covering a little bit later on the course. So let's recall back to the first lecture, what are some of the competencies that employers actually want? So intermediate information security, demonstrated ability to install, configure, troubleshoot, maintain networks, hardware, software, and so on in a secure manner to ensure their CIA. Utilize security solutions, access control, intrusion detection to defend, monitor, remediate, and so on. Now we have the ability to actually do this. We can install, we can configure, we can do all of those different things to help maintain confidentiality, integrity, and availability. And we have the ability to do something like access control now too. Ability to maintain and repair commonly used appliances, so that would be updating. We know we have an ability to do that. We can start to diagnose, we can start to go through some of the software and so on very effectively. Some of the technical skills too, information systems, Linux and Unix. We have a good understanding of that now so far, and we're only 3 lectures into the course, so these are some of the things that you can start to put down on your resume once you've gone through the assignment, that you actually have some ability to go through a Linux system and execute some basic systems administration tasks that actually help out in terms of information security. Now, what I went over was very, very, very brief, and sometimes I may have gone through it a little bit quickly, but that's okay. There's a lot of Linux resources that are out there, a lot. And I would strongly recommend that you practice your Linux commands every day. You get rusty with them very quickly, actually. But go through and see some of the other Linux distributions that exist. Try installing them. They're actually pretty easy to install. You saw how easy it was to install the virtual machine for this particular class. There's different types of best practices and fundamentals. These are the types of resources that systems administrators have to constantly keep themselves up to date on. There's different types of beginner guides if you're completely new to Linux and you want even more in-depth view on how Linux operates. You can see these beginner guides, and there's dozens of more resources that are out there. This is just a handful and a sampling of them. So these are a lot of review questions. I'm not going to go through them. You can start to see that these are a little bit more memorizations of function of the kernel and the shell and the paths, what's the difference between a relative and absolute path and that type of stuff. And we covered all of that within this particular lecture. But I strongly recommend that you do the review questions on pages 78 through 79. Try doing it hands-on as well in this particular slide and on your virtual machine too. That's what really the virtual machine is designed for you to do, is to play around with it and so on. If you accidentally delete the entire file system, go ahead and delete the entire file system. Just reinstall the virtual machine and play around with it. Get your hands dirty. Security is a hands-on sport, so definitely go in there and start to play with it a little bit and get a better sense of how Linux operates. As always, feel free to reach out to me if you have any questions. Thanks.